good morning to my friends and my lecturer here. So today we would like to do the presentation for the displacement and the velocity and also the acceleration, because all of these they are bound together. So first I would like my friend here, Kamil, to explain what is displacement for it.
Displacement, length of the straight line, the location is it can be the shorter distance from the starting point and the ending point. The SI unit for displacement will be and for the mass I will dari data explain about this displacement.
Displacement merupakan jarak yang dekat daripada titik A ke titik B. Titik A ke titik B melalui displacement adalah dekat. Kalau distance merupakan jarak. Kalau dari A ke B, jarak yang jauh. Berdasarkan untuk explain lebih lanjut.
So as we see for this one, so I would like to use the marker pen to explain more deeper inside this displacement. So as we know, this one is the displacement and this one is the distance. So when we talk about displacement, I'll do here. So as we know, this is the point A and this is the point B. So as we know, when the point A goes to here, this is called displacement and also the distance. But when there is one more point here, C, and the point travels to here also, this is called the distance. But for the displacement also the same. And then but if we travel like this, and if we travel back, for example, this one, the distance here is 5 meter, and this one is 5 meter also. So when we travel from A to C, it will become 10 meter. And then when it travel back, it add another 10 more meter to it, so the total distance for it will be 20 meter. But for the distance, for the displacement, it will be the other way. It will be 0, because when we talk about displacement, it will be the shortest distance. So when it goes back to the starting point here, the displacement will be 0. So what the other team just explained just now, this one is not explained, so I will be explaining it now. So that is all for the displacement. So next we will go on to the velocity. So as we know that the definition for the velocity will be the rate of change of displacement, and the unit for it will be meter per second. As the formula for it will be V equals to displacement over time taken. So for the displacement, for sure will be in meter. So there is a video for it. So this is the experiment that we carry out. We start from the point A to point B, and the the displacement for it will be taken down, and the time taken will be taken down also. So how are we going to measure the displacement for it? So we will be using a ruler, and then this is the starting point for it. So we will start measuring from here until here. This is the ending point. Actually, so it's just an example, so it might not be accurate now. the displacement. The displacement will be 92 cm. And the time taken for it will be 1.245 seconds. So now I will teach you how to find the velocity by using the data that we got from the experiment. So it will be, so as we know, the velocity would be v equals to d over t. The t is the time taken. So first of all, we have to see the data given. Here is given cm, so we have to change the unit for sure into meter. So I will teach you how to change the unit also as well. 92 cm divided by 1 cm and times 10 negative 2 meter. 92 times 10 power negative 2 meter. So the value for it will be 0.92 meter. So back to the formula for the velocity, it will be v equals to d over t. So we will substitute in all the value inside the formula. So it will be 0.92 over 1.245. So we must have a calculator here to calculate the value for it. So we apply it all inside the calculator. And then the answer will be 0.739 meter per second. The meter per second is the SI unit, the unit for it. So this is all about the velocity. So now I would like to pass the speaking to Faris to talk about the acceleration.
Acceleration, the rate of change of velocity. If acceleration is in the same direction as the object speed up and is known as acceleration. If acceleration is the opposite direction as the object slow down and is known as retardation. To calculate the acceleration of an object, divide the change in velocity by the time. A equals to final velocity minus initial velocity over time of velocity over time. I want to pass to Faris to explain more.
As we know, the acceleration is the rate of change of velocity. So I will show you a video. For example, by using a board and a ruler and a table. So this is the first point, start starting point and the ending point.
Yeah. Wait, I will make it.
So we will start here by using a board. This is the first point, starting point and the last point. So we start the board. Moving. Okay. To get the acceleration, you need to have a final velocity minus by initial velocity over time. How to measure displacement? You need to take a distance by using a ruler. This is the process of how to take the distance, the displacement. So will be length will be 74.56. I will teach you how to convert this cm to meter. 74.5 cm. And negative 2. So 74. So to get the acceleration, use this formula. Final velocity minus initial velocity over time. So define the final velocity. Final velocity is 0.745 minus to 0. Okay, first we find the velocity. The velocity will be 0.745 divided by 0.69 meter per second. So the answer, acceleration 0.69 minus to 0 over time. Time will be 1.08. So the answer is 0.38 meter per second square.
So after Haris had taught us how to find the acceleration, so I think there is nothing left to teach you all about the acceleration. So I would like to end our presentation with a conclusion. So as we know that physics is all related in our daily life, so many things is bound to physics. Like when we walk, there is displacement, right? Velocity, acceleration when we run also. Pressure when you want to drink with a straw. There is pressure there, atmospheric pressure acting outside the liquid. Anything is related to physics actually in our daily life. So I hope you all enjoyed our presentation. Thank you.